interview was good. Thank you, sir.
Okay, sir, I will let it.
That was observable that your presentation styles were
Yes, sir. Yes, sir.
updated as per the presentation style structures which was presented by Professor Jiva Khan.
Yes, sir, I will update it.
Modify those accordingly. Speed and the pace at which you are talking about your subject was nice. You can make things more interesting, more engaging.
Yes,
That
sir.
one keep track. It is not only for you, it goes for each one of us.
Okay, sir.
Thank you.
Thank you, sir.
Yes, now Rajiv Yadav. Ranjit Yadav, sorry. Please, Ranjit. After Ranjit, who will do? Anyone January born? Okay, Vivek, you will do after that. Fine? And Atul, keep the time for Rajiv, please.
Yes.
Yes.
Okay, sir. Today I'm going to present on half adder and full adder, and myself is Ranjit Yadav. I'm the lecturer EC in Government Polytechnic, Daman. Can you see the heading which I have written? WIHJYTD and something else. Any idea what I have written there? Did you see this? Do you get any idea what I have written?
Idea,
Very
sir.
good. This is what I want in my class. Once we started, we should get some idea what we are going to study now. So I will give you an idea that it resembles here a calculator, and also you can see a laptop. Okay, so this too is not new. We all know very well that these images we see in every day in our day-to-day life. So this idea that I'm going to present now in today's session, that we are doing several sorts of the calculations, the addition, subtraction, and so on. In all that we use adder. So today I have choose the topic which I'm going to take now. So this idea has been guessed. Thank you, madam, for that. And what is prerequisite for this? The basic knowledge of Boolean function, the knowledge of digital logic gates like AND, OR, NOR, XOR, XNOR, pen and paper, and eagerness to learn in today's session. Okay, so all these topics already we have covered in the previous session. So without wasting much time, we'll go further. So what is the learning outcome for the today's session? Okay, first of all, we will try to design and construct the half adder, also the full adder circuit, and verify the truth table using the IC logic gates. Okay, then we will try to list the several applications of the half adder and full adder in real time. So what is half adder is all about? A half adder has a two inputs for the two bits to be added and two output, one from the sum and other from the carry into the higher adder position. When I'm saying this, we understood very well that a half adder is a circuit which takes two input and give us two output. The output is labeled as sum and carry. To realize this operation, we must understand the truth table. As it is a two input, we will take the binary, as I told you in the prerequisite in the last session also I have finished. We have to go with the formula 2 to the power n, as the n is nothing but it resembles the input. So let me write it here 2n, where n is nothing but it represents the inputs. So as you can see, we are saying here two inputs, so 2 square is nothing but 4. Okay, so we will get four different combinations of the input. So 0 0 0 1 1 0 1 1. In the previous session also I have given you logic of 8421. If you don't remember that, you can if as per your number of inputs you have to select, like if it is a 4 we will go with 8421, if it is 3 we will go 321, if it is 2 we will go with 2 and 1. Otherwise also there is a logic to remember this. We will go with the first one 2021 and the last one will go with 0101. Now we will add it. What addition we have to do? The first question, the answer should be sir, binary addition. So now let us try to understand in the binary addition form. 0 plus 0 is nothing but 0 and the carry is also 0. Similarly 0 plus 1 is nothing but in the sum we will get 1 and the carry is 0. 1 plus 0, same 1 and 0. And this is the peculiar thing that we must remember, that when we add 1 plus 1, we will get 10. So many of you might wonder why I have written in here 0 and here 1. We all know in our school days that this is nothing but your sum and this is nothing but your carry. But 1 plus 1 is 2 in normal arithmetic operation. However, as I told in the previous session also, in this subject we are going to perform with binary. So 1 plus 0 is nothing but 10. So we will write here 0 and here we will write 1. So based upon this, okay, the input and output we have to design. Now, in the sum, when you want to write an expression, you will choose where you have 1. So I have written here 1 and 1. It is in second term and third term. So with this one, we will see this row. If we see here, it's a 0. That means A. So A bar. It is a 1. So we will write in the same form, that is B. Plus, because it's a mean term, here again we have another 1 in the sum. So 1. So here it is 1 A, so we will write directly A, and here it is 0, that means B, it is B bar. So this is nothing but this is an XOR gate which we already covered. Then next we will see the carry. So here it's a carry, only one term we have the value as 1. So we will see this row. So here in both A and B it is 1. So we will write straightforward A and B. So now we got the expression for sum, also the expression for the carry. Now this is the circuit diagram, as in the previous slide I have shown you. This is a sum and carry. This is nothing but this is AND gate, and for sum we are using nothing but the XOR gate. So this is the design for it. We are using as the same input, two input, we are connecting to both this. The IC which we are using is 7486N for XOR gate, and this is 7408N for the carry. And we got the same expression. We can verify it with the truth table. So we have the pin diagram for it, and we have already discussed what is the truth table for the AND gate. The AND gate expression is nothing but y equal to A dot B. So you just multiply these two inputs. We will see that whenever your both the inputs are high, then only you will get the input and output as high, otherwise it is 0. So this is the IC diagram which we are using. Similarly, for the XOR gate also we will see A XOR B. So we have to perform this operation. So we'll complement it and we will perform. So we'll get always, whenever there is a dissimilar input, dissimilar I'm saying, stressing on this point, dissimilar, that means you can see here in B it is 1, A it is 1. So we'll get in the output 1 1. Whenever both the input are similar, either it is 0 or 1, your output will always be 0. You can check it out. Okay. Now what is an application where we can find out? In ALU, already I have shown you. In the computer we are using half adder is also used to make the full adder. As a full adder required 3 inputs, the third input being an input carry, that we will be able to cascade the carry bit from one adder to the other. So this is nothing but, before jumping on to the full adder, we got a gist why we should study the full adder. Because in half adder the limitation is we have only 2 inputs, but in full adder we will have 3 inputs. The same combination as I told you, 2 to the power n. So here we have n equal to 3. So 2 cube is nothing but 8. So we have the 8 different combinations of input. So we will go with the logic of 4 to 1 to set this input. And simply, as I have explained you in the half adder, you simply add it. We will get the truth table. Okay, because this is similar operation, I'm just giving you a task also so that you can perform it. Okay, so here also what we have to do is, wherever we have got the one term, we will take that for finding out what will be the expression. So I will just take one or two from this. So rest of the thing I have already written, and you can also practice. Okay, so here only in the C we will have 1 and A and B 0. So it will be A bar, B bar, C. See, this is a term. And the next term A bar, B, C bar. So we got this term. And for the last term also we have got it here. Similarly, we will also do for the carry operation as well. Fine. I hope this is clear. Now the same formula or the logic what we have done for the half adder, same we will do for the full adder also. Okay. So we will have the XOR gates to find out the sum, and for carry we will have the AND gates. Fine. So the pin diagram already explained to you how we are determining the input and output operation. This is for your practice session, one example has been designed. See, it is very flexible. We can design n number of combinations of full adder as per our requirement. So here one example also I put the binary addition. You can see 0 plus 1 is 1. 1 plus 1, as I explained you in the half adder, it is 10. So we are writing 0 here. 1 will come here. 1 plus 1, 10. 10 plus 0 is again same thing. 0, 1 will go here. 1 plus 1, 10. 10 plus 1, 11. So we'll write here 1 and carry here 1. So like this examples also in exams, the paper, you will have such questions where you will given the binary additions. So you can perform as I shown you in this example. Now, where we can use the full adder? Okay, in the basic building block of on-chip library, it is configured to perform the arithmetic and numeric computations. In ALU, we are using in our mobile phone also we have this all this in our processor. Okay, to calculate the address, the table indices, and the similar operations. What is a summary of in today's session? We have learned the half adder of the truth table, the logic function, how the design procedure we can perform with the IC. The IC number also specified with respect to the pin diagram. Similarly, we done for the full adder. And then we have learned the several applications of half adder and full adder. And also I told you why we should go with the full adder. Okay. Then what we will learn in the next session, this is very important for you. We will learn and practice the designing of half subtractor and full subtractor circuit and verified truth table in the next session. So I'll give you 10 minutes, you will do by yourself and then we will do it in the board. Okay, so to verify it. Then we will also discuss about the application of half subtractor and full subtractor as we did in the today's session for the half adder and full adder. Okay. Then, what is an assignment? Is there any assignment today? Of course. What is an assignment? We will be doing the simulation of half adder and full adder. As many of you have a mobile phone, also you can do in the virtual lab. If you do not have laptop, you can do in virtual lab. If you have a laptop, I will suggest you to do in the multi-sim and verified truth table. And practice the half adder and full adder circuit diagram which we learn in the today's session. I will also share this particular slide in our classroom, so from where you can get it. Okay, so you will verify it and note down in your assignment notebook. It will also be a practice for you. Any question answer you can ask now, or if you want, you can also reach me in a different ways as you already always do, right? So any question in today's session? Happy to answer.
Nice presentation, sir.
Thank you.
Sir, your presentation style was good. The only problem was time was exceeded. Else, everything was good.
Thank you.
And my personal suggestion, if you want to take, is that it would be better if you just try to put some graphics in the application slide. I mean, you may just put the figure of the application areas and you may just elaborate it so that the people might, think what would be the application.
Thank you. Definitely, we are doing it actually in the class. It is as per the time constraint. Several images
Yes,
it takes time. So
definitely. You have given quite a very nice presentation. I appreciate it.
Okay. Rajiv ji, good presentation.
thank you, sir.
Jinil, are you there?
Yes, sir. Yes, sir.
Yes, yes, sir.
Yeah. Your feedback, please, on this
So it
presentation.
was nice. He is explaining with the example very well. Good presentation.
Okay. Anything missing?
Sir, I've used the timer, right? I think there is some buzz or something that. So, sir, then after the once timer is on, right? I think, am I right, sir? Have you
Yes,
used the
I put the
timer?
timer for 8 minutes, and to conclude it in the next 2 minutes, I've just put the timer so that I should not waste other times. So might be 1 minute or something has been exceeded.
Yes, I think that is the plus point for the any presenter.
Very good observation, Kumalji. This is exactly we should be doing and taking care of others as well as your own time. So wonderful to see such practices, innovative approaches, bringing in your own